This video, we're going to do some guided exam question practice on a question that came up on trends in first ionization energy. So it's from 2003, it's quite a long time ago, okay, and but it's typical of the type of question that gets asked, okay. Now it was a 25-mark question, so we see here we've got 7 plus 12 plus 66. Altogether, that's 25 marks, which means this is 10 minutes, okay. So you get 10 minutes to do this, it's half a full question. So I'm going to get you set your timer and we'll get started. So do that now. All right, so we're ready to go. All right, let's have a read here. It says the diagram shows a sketch, okay, of the trend in first ionization energies. So that's what we're looking at, first ionization energies, for the elements 3 to 10 in the periodic table. Now, it might be a good idea at this point for you to look at your periodic table and see what elements they are. All right, so if you pause your video, get your periodic table and find out what element 3 is and what element 10 is. All right, so hopefully you figured out that element 3 is lithium and element 10 is neon. Okay, so we're looking at the first ionization energies going from lithium to neon. And just as a bit of background, this is what we call period 2 of the table. This is period 2 of the periodic table. So we're essentially looking at, let's look at the graph now at this stage. We're looking at atomic number down here. So here we see from left to right, the atomic number is increasing. Okay, and here on the y-axis, we're seeing the first ionization energy is increasing. All right, so let's look at the general trend. What do we spot? Okay, so before we even read any questions, let's just have a quick look. Okay, so what I'm seeing here is, and this is a graph you should recognize from class, is I'm seeing as a general increase in first ionization. Generally, it's just going up. Okay, so first ionization energy is increasing. But I'm seeing a couple of things that seem a bit out of place. This one and this one seem a little bit out of place, and maybe this one as well. If I was to draw a kind of a where I'd predict, I would expect it to be kind of like that. So it seems like this one's a bit high and this one's a bit high and that one's jumped up there as a bit too high. Now there must be some reasons for that, and hopefully you guys know that already. But let's go back to the questions. Look what it says. It says account for the general increase in ionization energies across these elements. Now, it's not asking you to refer at this stage to these specific things. It's not asking you about these. It's asking you about this slope here. It's asking you about this, the general increase. Account for that. So in other words, why do first ionization energies increase across a period? You guys should certainly know the answer to this. But let's go ahead and line up our question. So we know what we want it to look like. We're talking about, well, why is there an increase in first ionization energy? So i.e. we're going to let stand for first ionization energy. When we move from lithium to neon. All right, so pause the video and write down the reasons why you think that is. Okay, so hopefully you have that done. If you don't, I'm going to do a quick bit of revision here. If we look at lithium, one of the things we will notice is, or one of the things we should remember is that the atomic radius of lithium, when we move to neon, what happens is it gets smaller. So this here is the atomic radius of lithium, and this here is the atomic radius of neon. What difference is that going to make in terms of how difficult it is to remove the outer electron? What difference is that going to make? Another thing to consider is the number of protons each of these things has. Lithium has 3 protons, 3 positive protons, and neon has 10 protons. Okay, so what do we say? What is this thing that's getting bigger if we've got more protons? Okay, so I'm going to pause the video and answer the questions if you haven't already done that. Account for the general increase in first ionization from lithium to neon. And these here are clues as to the answers. Okay, right, so hopefully you have done this. We have talked about the atomic radius. Atomic radius. What happens to it? Decreases. So that's one of the things that happens. What does this mean? Atomic radius decreases, so what? Well, now the outer electron is closer to the nucleus. If the radius is smaller. So if it's closer to the positive nucleus, it's harder to remove. Closer to the nucleus. So it's harder to remove. The other thing is, what do we call this here? If we're going from 3 protons to 10 protons, this is what we call the nuclear charge. And what's happening to it? The nuclear charge has increased. Okay. And with the nuclear charge, there has been no extra what? We haven't, as we go across, all the electrons that we add go into the same shell. Okay, so we say, so these are, as we add a new electron each time, it just gets added to the same one. So there's no extra screening. All right, more than enough there to help us get all the marks. Okay, so hopefully we had these points. Okay, that the atomic radius decreases and the nuclear charge increases. These are the reasons why it's the first ionization energy increases. Right, let's go back. That was worth 7 marks. Let's go back. This one's worth 12 marks. So they're going to be looking for a bit more detail here. What does it say? Explain why the ionization energies of element number 4 and element number 7 are exceptionally high relative to the general trend. So 4 and 7. So that's these two here, this one and this one. Explain why those are exceptionally high relative to the rest. So let's lay out the question. Why are, so part 2, why are BE and N exceptionally high? What is causing that? Pause the video and write down the answers for that, for each one. Okay, now if you haven't been able to do this, what my suggestion to you is you begin by writing down the electronic configurations for element 4 and element 7. Begin by doing that if you weren't sure how to answer this. Pause the video and do that now. Okay, so hopefully you've written down the electronic configuration. Element 4 is beryllium. It has an electronic configuration of 1s2, 2s2. Element 7 is nitrogen. It has electronic configuration of 1s2, 2s2, 2p3. Right, now that you've written out the electronic configurations, can you tell me something about them? What's special about these? That means they have a higher first ionization energy. So I've given you so many clues. If you can't get this by now, I'm getting worried. Okay, so pause the video and write down the explanation for why these two are exceptionally high. Okay, right, so hopefully you're looking at this here. This is the outer 2 electrons and they have filled the 2s sublevel. So we would say beryllium has a full 2s sublevel. This gives the element extra stability. So we want to mention extra stability. This makes beryllium extra stable. It's harder to remove the outer electron. What about this one? Well, this one has some special configuration here. What is that? Well, if you didn't get the first one, hopefully now you can pause the video and tell me about this. Okay, so this is a half full 2p sublevel. It's half full. And half full has extra stability. So this gives the atom, this gives nitrogen extra stability, and it's harder to remove the outer electron. Okay, so all of this is important. So obviously, I'm not writing out a full sentence for you. I'm giving you the tools so that you can write a full sentence out of this. Okay, so you should be putting this into a couple of sentences or a paragraph or something like that. Okay, so one last opportunity to pause and take down and add anything that you need to do now. Okay, let's go back to the question. How does the definition of second ionization energy differ from that of the first? This is 6 marks. How does it differ? Okay, so there's a couple of ways you can do this. So we're going to say, it wants to know how are they different. So we're going to say, well, we're talking about first Actually, do you know what? I'm going to shorten this even more. We're talking about first ionization energy versus second ionization energy. Now, I'm going to, again, we're asked to compare things, so I'm going to do this in a table. Okay, I'm going to say first IE. I'm going to say second IE. When we're asked how do the definitions of first and second ionization energy differ from each other, so we could go ahead and isn't that what it says? Let me just double check. How does the definition for the definition for first ionization energy differ from that of the second ionization energy? So we're talking about the differences. Now we could literally go through the two definitions here. So write the definition of this here and this here. And we could probably show this using equations either. Okay, so we could use it showing equations. So pause the video and compare them for me now. Explain how the two definitions are different. All right, so the first thing to note is that, well, I'm going to start by writing the two equations down. So if I was writing the general equation for the first ionization energy, I would start with an element x. I would show what happens. Well, x, if it's the first ionization energy, it involves removing the first electron. So it's going to become x plus 1, and here's your first electron that's been removed. If it's the second ionization energy, well, then we've already removed the first electron. So essentially, we are removing the second electron from a monopositive ion, +1 ion. Okay, so here it becomes x plus 2, and here is your electron again that's being removed. So what do we want to say? Well, we would say the first ionization energy, the electron is removed from where? Electron is removed from what type of a thing? Removed from, what does this show? Okay, and then here, what is the electron being removed from? Removed from. So again, this explains the differences in the definitions. Now, you could have written out the exact definition that you learned for each one, but I'm trying to show you here how to just compare them. Okay, well, this here represents an atom. Electron is removed from an atom. This is a ground state atom. Okay, it's a neutral atom. Whereas over here, electron has been removed from a monopositive. What this means is a +1 ion. That's the difference between the two definitions. If you wrote them out, that would be the difference. So first ionization energy is the minimum energy required to remove the most loosely bound electron from an atom in its ground state. Whereas second ionization energy would be the minimum energy required to remove the most loosely bound electron from a monopositive ion in its ground. No, not in its ground state. A monopositive ion. That would be it. Okay. All right, guys. So let's quickly just go and pull up the marking scheme for this, and we're going to take a quick look. Let's look here at the first one. So part 1, we were asked to explain the general increase in first ionization from lithium to neon. What did we say? We said that the atomic radius decreases. So we said atomic radius decreases. Let's look in the marking scheme. What does it say? It says decrease in atomic radius. There it is. So 1 correct, we have 4. So there's 4 for the first one. What else have we said? Outer electron is closer to the nucleus. That's not there because that's the same thing as that. Okay. And what else have we said? Nuclear charge is increased. And we said no increased, no extra screening. Let's take a look. There, look, increased in nuclear charge. Okay. So there is the second one. So we got both correct for 7 marks. So there, 7 marks. Notice there's nothing about the screening. That wasn't there. Okay, by itself, that's no good. We need to be talking about the nuclear charge. So if you said atomic radius decreases, screening does not increase, not enough. You have to be talking about the nuclear charge. Okay, so we've 7 altogether. Sorry, I better get rid of that 4, or I might count 11, give myself 11 there altogether. But let's look at the next bit. Explain why beryllium and neon are exceptionally high, or beryllium and nitrogen are exceptionally high. Here's element 4. Okay, what does it say? It says the outer sublevel is full. The outer sublevel is full, which is what we've said. You could have got it just actually for writing down the electronic configuration. Wow, didn't realize it would give you that for that. So we had that done there, okay. But then I think it's important that we don't just learn that. We want to say electron has been removed from a full 2s sublevel. Yeah, I mean, given increased stability. I mean, we've said loads of that. So that there, we're definitely getting on 3 marks for that. And the next one, well, here we've got the electronic configuration, which is essentially what they've done there. And they're giving you the marks for that, which is, again, crazy because we haven't explained it yet. Half full 2p sublevel. There we go. Look, half full p sublevel. Happy with that now. That's our 3 marks. That's 6 altogether. Oh no, sorry. Okay, so there's actually 6 marks going for each part of this. So we're saying full 2s sublevel, that's worth 3 here. Full 2s sublevel here. And that gives increased stability. That's the second 3. So there. So 6 on the top line, and again, increased stability on the bottom line, coming from half full 2p sublevel. So 3 there and 3 there. Okay, so 12 marks going there altogether. Again, not bad at all. Pretty nice 12 marker there. What about the last bit? Compare the first and second ionization energies. All they wanted you to say is that the electron has been removed from a monopositive ion in the second ionization energy. Yeah, okay. That was it, really? It seemed to be. I mean, yeah, I prefer that we know it to this level over here. You see what they've done? They've done the same thing. They've written the equations, whereas we didn't. We wrote down, we wrote down the 2 equations. Look, if you've done anything like that, you've enough to get the marks, 6 marks. So again, that was 25 out of 25. Hopefully you realize or agree it wasn't too bad of a question. So that's it, guys. We'll see you in the next one.